Hello everyone, welcome to this next session in which we will be looking at Python's functions. So in this session we will look at several aspects of functions. So you should pay careful attention and you should type along as before in all of our previous sessions. Only when you type along will you kind of understand the nitty-gritty details of these functions. So why do we use functions? Well, functions are a means to do code abstraction, as in it gives us the following things. It allows us to reduce any duplication of code. So supposing you are doing the same thing multiple times with different values, you could put it into a function and call that function any number of times. This allows us to not have to repeat that same code multiple times. Because we have fewer lines of code, this also reduces the scope for any bugs and it improves the reusability of code, because once this function is written, I could use it, other people could use it. The other nice thing about functions is it abstracts out some functionality. So let us say we were doing string.lower. The lower method or the upper method has been written by somebody else. We don't know exactly what it is doing inside. So what this allows us to do is, if you give a function to somebody, they don't have to necessarily know what it does or how it does it. They need to know what it does, obviously, otherwise they won't know how to use it. But the details of how exactly it is implemented are not necessary for you to know. This allows people to abstract the details of a function inside the function definition, and the user of that function simply knows how to call that function and it will solve it. For example, we made many plots in our first session. We used linear algebra routines. We did a lot of things. Each of those is some function which has already been written and provided for us. We don't know the details of that implementation, but if we call it, we get a desired result. So functions allow us to do this, and what we learn in this session is how you can define your own functions. So let us start looking at functions. Now this is something we have seen much earlier. We had looked at this in the first session on how to create simple functions. So way back when we were looking at NumPy plotting, we actually did plotting with lists and we did squaring of an integer, of integers. We then did wrote a function to square all of the elements of that list, things like that. We will now look at functions formally. So consider this function f of x, which should be returning the result x squared. Alright. Now if you wanted to define this in Python, remember that the caret operator, this is not valid Python, as in it will not give you the square of x. It's a valid Python syntax, but it will not give you what you expect. So in Python, if you want the square of a number, you can simply do x into x or x star star 2. So this function in this case is a Python function which returns the square of its argument. To call this function, you simply say f of 1 or f of 1 plus 2j or anything which supports the multiplication operator. So any argument that supports multiplication can be multiplied. So please try this little example. It's just 3 lines of code, 4 lines of code. Just try it out on an IPython session. Pay attention to the fact that this return statement is indented 4 spaces to the right of this definition. What you will notice is if you do f of 1, you get the result 1, but if you do f of 1 plus 2j, you get minus 3 plus 4j, which is the square of 1 plus 2j, right? So this function is very easy to define. So let us look at the details. This word def, this is called a keyword in Python, and this says that whatever follows is now starting to define a function. F is the name of this function, and how you call this function is by saying f open bracket, give it any of the parameters. X is the parameter of the function. Return is another keyword. So what does return do? It simply returns x star x. You can return pretty much anything you want from a Python function. So let us move on and look at a little more about functions. So please type this code. Remember, when you are entering this, you will have to enter 2 times here, you enter here, you will get this continuation prompt, hit enter again, and then you will get this, and then you call the function. So let me quickly do this myself. Notice that to call this function, you give it the function name greet, open parenthesis, close parenthesis, and now you hit enter and it does what we want. Please notice the following things. First, this function greet takes no arguments. You must always give this open bracket, close bracket. So if it takes a single argument, the single argument will be inside this. If it takes no arguments, you simply put open, close. You must define it this way. You cannot not specify these brackets. Notice again that this function does not return anything explicitly, alright. So which means when you call greet, it didn't give us any output. So let us go back to our terminal, it just printed this, alright. So it didn't return anything. So for example, if I were to say x is equal to greet, it still printed the value, but what do you think the value of x would be? Let's print x and see what we get. It says that the value is actually none. So what is the type of this x? It says that it's a none type. So which means there is this thing called none in Python, which is implicitly returned if you do not return anything, alright. So none is actually a data type, it's a immutable data type, and it is used for things like this in Python. So I can actually do x is equal to none, it's perfectly valid Python code. So none is a data type just like integers, strings, floats, alright. And if you define a function which doesn't return anything explicitly, implicitly it is returning none, alright. So in this case, so let's say we just created a simple function def f and said pass, syntactically valid, it's a simple function. Now if I call f, this function also returns none. It doesn't return anything explicitly, but implicitly it is returning none. And IPython will not print none for you, as in if you just do x, it will do nothing. Unlike if x was 1, if I did x, it will show you 1, but if x is none, it won't do anything. But if you printed it, it will actually print NONE, alright, with n being capital. Please pay attention, it's not small n. Okay, so if you do x is equal to NONE, it will say name none is not defined. It doesn't know what little none is. Alright, so bottom line is you can define a function that takes one argument here and returns the value here, or you can define a function that takes no arguments and returns nothing, or in this case it returns none implicitly. So the return statement is not mandatory in Python, alright. And as I said, none is a built-in immutable data type that is available, and you will see Python code that often uses none for other kind of, it's kind of like the C has this null value, like that Python has this none which is often used in certain areas. Please type this code. This is an example of a function that takes two arguments. So if you have two arguments, you separate them by a comma, so A comma B in this case. And note that it is returning one value, which is the average of A and B. Now let me type this. Now let us say I called avg1, 2, I will get 1.5 in Python 3, in Python 2 you will probably get, what will you get? You will get 1. Anyway, what if I did not pass two arguments? Will it work? Will it not work? What will happen is, it will say it misses one required positional argument B. So it gives you a helpful message saying there is a type error, average is missing one required positional argument. So in this case, you forgot to supply one argument, so you must supply the second argument. So pay attention to error messages you get and learn what error messages are caused when you make what mistake. That will make you a better programmer and you will be able to debug code much better. So let us move on. So we have seen three examples so far. The first, which takes a single argument, returns a single value. The second, which takes no arguments returns nothing. Third, which takes 2 arguments, returns something. Alright. So we have seen how we can define various types of functions, but one thing you should always make a practice of doing is, you should write documentation for each of your functions. To do this is very simple. All you need to do is you need to create what's called a doc string along with the function definition. So for example, if you did def this, you simply put a triple quoted or a single quoted string. If you have just a single line, I strongly suggest triple quoted, because then you can have multiple lines of documentation followed by whatever code you have. So please try this, type this out, and then on IPython you do avg question mark greet question mark and see what you get. Notice that when you do question mark, avg question mark will actually give you this doc string. It will actually show you the doc string, whereas for greet you will get no doc string. Alright, so let me quickly show you this. So def avg ab, notice that the first lines after my function definition I need to put a string, and I am not assigning the string to any variable. Now I can say return a plus b, now I do avg question mark. Notice that it says signature avg ab doc string return the average. Okay. On the other hand, if I say greet question mark, it says no doc string. So it's always a good idea for you to document your functions, because users will immediately see this documentation. And this is how, for example, when we did round question mark, again this doc string is available because someone wrote it. So you should also document your own functions. Alright, so let us move on. Let us see how we can return multiple values. Up to now we have seen the case where we return no values or return one value. Now let's look at the case where we can return 2 values. So please type out the following code. What this does is, it returns the area and perimeter of a circle given the radius, and the function needs to return both the area and the perimeter. So please try this. So I hope you have typed this out. So what has changed in this? Well, when we return, instead of just returning area or just perimeter, we simply say return area comma perimeter, and that's it. So returning multiple arguments is very, very easy. And when you return it, notice that if you just called circle 4, it will give you a tuple of values. Alright. Similarly, if you say a comma p is circle of 6, a will be the area and p will be the perimeter. So essentially again we are doing tuple expansion. So whatever is returned as a tuple, it's expanded and it's stored in these variables. So let me just try a simple example here. So we'll try a very simple example, 1 comma 2. Alright. So now if I say x is something, what is x? What do you think the type of x will be? Any guesses? It's a tuple. So now if I want to get the first element, x of 0 will give me 1, x of 1 will give me 2. X of 2 will be an error because it has only 2 elements. Now supposing I want to store this as 2 separate variables, I can simply do tuple expansion and say a comma b equals x, and then a will be 1, b will be 2. I could also do this as a comma b equals something. So notice that Python makes it very easy to define functions. So you should feel comfortable experimenting by yourself and learning more about how to define functions and what exactly it is doing. Thank you very much.